I am Dr. Pravina Piste, Professor in Chemistry at Reth Shikshan Sanstha's Arts, Science and Commerce College, Ramanagar, Burli. Today we will study here the Organic Chemistry, paper 10th for the BSc part 3rd. The name of the topic is Infrared Spectroscopy. Our inspiration, founder of Reth Shikshan Sanstha, Padma Bhushan, Dr. Karmveer Bhavrao Patil. This video is for educational purpose only, no copyright infringement. This copyright belongs to its rightful owner. The credit goes to respective video music composers and singers. The pictures, images, names and or photographs shown and or depicted in this video tutorial are for representation purpose for ease of understanding the subject. The pictures, images, names and or photographs used are for educational purposes only. Now we will study here the infrared spectroscopy. The last video that we have studied the characteristics of the infrared absorption of the functional groups such as the carbonyl compounds, that is aldehydes and ketones. Now we will see here the characteristics of the infrared absorption of the amines, nitrocompounds and aromatic hydrocarbon. Now we will see here the information about the IR spectrum in case of the amines. The NH stretching frequency occur in the range of 3500 to 3200 per centimeter. The primary amine, the secondary amine, the tertiary amine may be differentiated by using the infrared spectra. The primary amines shows the two NH stretching bands in the range of 3500 to 3300 per centimeter, whereas the secondary amines which shows only one band in that region, while the tertiary amines do not show any NH stretching band in the spectrum. The NH stretching, that is doublet for the primary amines and singlet for the secondary amine, observed at 3335 per centimeter. NCH2 stretching, which is observed at 2780 per centimeter. The NH2 scissoring as well as the NH bending, which is observed at 1615 per centimeter. When there is an aromatic compound, then aromatic CN stretching, which is observed at 1360 to 1250 per centimeter, while the aliphatic CN stretching, which is observed at 1220 to 1020 per centimeter. The NH2 wagging and twisting, which is observed at 850 to 750 per centimeter, while the NH wagging, which is observed at 715 per centimeter. In neat liquid samples, the NH bands are weaker and sharper than the OH band. The primary, that is the NH2 amines, shows the two absorption bands. One of them is the symmetric, the second one is asymmetric stage. Now see here the symmetric and asymmetric stage. Now this is showing two bands. One is the symmetric and the second one is the asymmetric. It indicates that the presence of the primary amine. It is observed nearly at the 3400 per centimeter and 3300 per centimeter. It is not possible to assign the symmetric and asymmetric bands by inspection, but it is assumed that the higher frequency band is due to the asymmetric vibration, whereas the lower frequency band results from the symmetric vibration. That is, here the 3442, which indicates due to the asymmetric while the 3360 per centimeter absorption band, which is due to the symmetric vibration. Now in the dilute solutions, the two frequencies are shifted to the higher values. The aliphatic secondary amines show only one NH stretching band at 3300 per centimeter, whereas the aromatic secondary amines gives a stronger NH band near 3400 per centimeter, while the tertiary amines do not show any NH stretching band in the absorption spectrum. The NH bending mode appears as a medium to strong intensity band in the range from 1640 to 1560 per centimeter. In aromatic secondary amines, the NH bending vibration is very weak and usually is not observed. The NH vibrations in the aromatic compounds often overlap the aromatic C-double bond C ring or absorption, which also appear in this region. Sometimes an out of the plane NH bending vibration also appear broadband in the range of 850 to 750 per centimeter for primary and secondary amines. These bands appear in the spectra of the compounds determined as a neat liquid and are seen most easily in the aliphatic amines. The CN stretching absorption occurs in the region from the 1350 to 1000 per centimeter as a medium to strong band for all amines. Aliphatic amines absorb from 1250 to 1000 per centimeter, whereas aromatic amines absorb from the 1350 to 1250 per centimeter. The CN absorption occurs at the higher frequency in the aromatic amines because the resonance increases, the double bond character between the ring and attached nitrogen atom is also the increases. See here the CN stretching, which is observed at 1281 per centimeter. Now this is the IR spectrum of aniline showing a 2 NH stretching band at nearly at 33 to 3400 per centimeter. The two bands itself indicate that the presence of the primary amine, and the CN stretching due to the aromatic, which is observed at the 1281, indicates the presence of the aromatic amine. Now see the next one is the IR spectrum of diethyl amine. Now this is the secondary amine. Diethyl amine is the secondary amine. See the structure of the diethyl amine. Now diethyl amine, that is NH group, is attached with the on the both the sides the ethyl group. It is the secondary amine. Now in the secondary amine, it only gives one stretch, that is the one band, that is at 3281 only, indicates the presence of the secondary amine. Now this showing at the 2968 and 2814, this is due to the CH stretch due to the CH3 as well as the CH2 group, and the CH stretching, which is observed at 1046 per centimeter, indicates the presence of the secondary amine, and we can determine the structure as the diethyl amine by using the IR spectrum. Now the next you will see here the IR spectrum of NN dimethyl aniline. Now here the nitrogen is the tertiary atom, that is the amine is the tertiary, and it does not shows any absorption band with respect to their positions, that is the 3300 to 3400 per centimeter. which indicates the presence of the tertiary nitrogen atom, that is the amine, tertiary nitrogen amine group. Now here it shows only the respected the CH stretching due to the aromatic, as well as here it is showing due to the CH3 the group, and the corresponding the CN stretching which is shown at the, this is the aliphatic CN shows at the 1190 per centimeter, and this region is showing the presence of the aromatic ring, indicates the aromatic amines, and it showing the tertiary amine, that is the NN dimethyl aniline. Now next one, we turn to the nitro compounds, IR spectrum of nitro compounds. Now let us see a little bit about the information about the IR spectrum of the nitro compound. The nitro group gives the two strong bands in the IR spectrum. In aliphatic nitro compounds, the asymmetric stretching vibration occurs in the range of from the 1600 to the 1530 per centimeter, and symmetric stretching band appears between the 1390 to 1300 per centimeter. You can take the example is the 1-nitrohexane. Now in that it absorbs at the 1500 per centimeter and 1380 per centimeter. Normally its lower frequency band is less intense than its higher frequency band. In contrast with the aliphatic nitro compounds, aromatic compounds gives the two bands of the nearly equal intensities. The conjugation of the nitro group with an aromatic ring shifted the bonds to the lower frequency and appears at the 1550 to 1490 per centimeter and 1355 to 1315 per centimeter. In case of the nitrobenzene, it shows the two absorption bands strongly at 1525 and 1350 per centimeter. If there is a nitroso group, then it gives only one strong band, and that appears in the range of 1600 to the 1500 per centimeter. Now see, this is the IR spectrum of the 2-nitropropane. Here this is shows the CH stretching, the presence of CH stretching due to the CH or the CH3 group. This is the presence of the NO group, and here it shows the two group. One is at the 1557, the second one is the 1388 geminal dimethyl. We showing this indicates that this is a nitro group, presence of the nitro group and 2-nitropropane present. Now the next you will see here the IR spectrum of 3-nitrotoluene. Now here it is showing a CH trace at the similar the position, while the NO stretching is observed at the 1537, while the second observed at the 1358 like the previous one. Now see the IR spectrum of nitromethane. It also showing the two NO stretching band at the 1573, and the second one is observed at 1383. The CH stretch is observed at this one due to the CH3 group. Now see the in case of the aromatic compounds. Now here we have taken here the example, that is the toluene. Now in this aromatic hydrocarbon, it gives the CH stretching that is the CH stretches are to the left of the 3000 and the alkyl CH stretches are to the right of the 3000. This means that the aromatic CH having the frequency the more than that of the CH stage than of the alkanes, that it is observed at 3099, 3068, while the CH3 stage which is observed at 2925 per centimeter. Now see here the CH stage due to the alkyl group and this is due to aromatic the CH. Now the absorption band at the 1614, then 1506, 1465, which indicates the presence of the aromatic ring. Now there is a CH bending vibration, CH bending vibration, stretching vibration, which is observed in the fingerprint region, in plane, out of plane, like this one. Now the next one is the IR spectrum of isopropyl benzene. The aromatic bending modes, the CH bending, which is here, the observed here, see here, indicates this is the, we know that we have already studied, this is the aromatic region. We start with the 909 to 667. If there is an absorption band, indicates that the compound must be contain the benzene ring. Now there is a in this example there is a isopropyl group, that is there is a CH stage which is observed at this one. There is overtone combination bands is observed, and here there is a C double bond. This is a double bond region, that is the C double bond C is present in the benzene ring and which indicates the presence of the aromatic hydrocarbon. Now the next one is the typical infrared absorption values for the various types of the bonds. Now for the next video, visit Rayat Shikshan Sanstha's YouTube channel Rayat Knowledge Bank. Now thank you very much for watching this video. Thank you.